Hello everyone. I thought let me do some interesting tidbits about organic chemistry. So I thought let me start with the shapes. So we know carbocations are trigonal planar in shape and carbanions are pyramidal in shape. But why? You can very easily say simple. Carbocations are sp2 hybridized. We know that sp2 hybridized orbitals are trigonal planar in shape and carbanions are sp3 hybridized, and therefore sp3 hybridized means shape should be tetrahedral, and because one of the lobes will be having one of the 4 lobes of the sp3 hybridized orbitals will be having lone pair of electron, therefore it is pyramidal in shape. But my question is why? Why is carbocation sp2 hybridized and why is carbanion sp3 hybridized? So the interesting thing is you have to understand the stability of electrons in the orbitals. Now we know that s orbital is closest towards the nucleus, right? Then comes p orbital. Now because s orbital is spherical in shape, it has much higher penetrative effect than your p orbital. So it is very close towards nucleus and p orbital is much farther away than that. So what happens when electrons are in s orbital? They are more strongly attracted towards nucleus. And when they are more strongly attracted towards nucleus, more energy will be released. Anywhere where a more stronger attraction is there, more energy is released. So it is more favorable, the system is more stable. So one thing is very clear, electrons in s orbitals are more stable than electrons in p orbital. Now let us talk about hybridization. So we know generally when s and p combine, they form sp, sp2 and sp3 hybridized orbitals. Now sp, you know, it has 50% as character, sp2 has 33% and sp3 has 25% as character. That means sp orbital is closest towards nucleus than sp2 than sp3, right? Because whichever has more s character, of course s is closer towards nucleus, so more s character closer towards nucleus. Therefore electrons are more stable in s orbital, then sp orbital, then sp2 orbital, then sp3 and then only p orbital. So electrons are happiest in s orbital, least happy in p orbital. Moving on. Now let us look at carbocation, right? So if you look at carbocation, two possibilities were there. One was correct, one was wrong. Let us look at the correct first and then we talk about why it does not happen otherwise. So we know carbocation is sp2 hybridized. So what happens? There are 3 sp2 hybridized orbitals which are shown here and there is a vacant p orbital. Now vacant p orbital does not have electrons, so we do not care about the stability of this orbital, right? We are concerned about the electrons, about the orbitals in which electrons are there. So here the electrons are in sp2 hybridized orbital. Imagine if carbocation is sp3 hybridized, then should have had 4 sp3 hybridized orbitals. So what happens? Anyway we are not concerned about this orbital because this orbital is vacant. All I am concerned about is where the electrons are there. So electrons are in 3 sp3 hybridized orbitals. So I am comparing 3 sp3 hybridized orbitals with 3 sp2 hybridized orbitals. So what did we say? Where electrons are more happy? Where electrons are more stable? In sp2, because sp2 has more s character, sp3 has lesser s character. So here electrons are closer towards nucleus and therefore more energy released, more stability, and therefore carbocations are sp2 hybridized, and you know sp2 hybridized is trigonal planar in shape and this is the trigonal planar and is the vacant p orbital. Had it been sp3, then it should have been tetrahedral in shape. So the 3 bonds would have been pyramidal and this vacant orbital would have been there, but this is not right, and what is right is this one, right? Let us see for carbanion. So for carbanions what happened? Now again two possibilities are there. One, sp3 hybridized, second is sp2 hybridized. So when it is when it is sp3 hybridized, I think this is some mistake is there, this tick. So when it is sp3 hybridized, it will have 4 sp3 hybridized orbital, 1, 2, 3, 4, and out of that one sp3 hybridized orbital has just the lone pair of electrons. Other sp3 hybridized orbital is bound with something else, with hydrogen or some another carbon, but basically these are bond pair of electrons and these are lone pair of electrons. Now understand, the repulsion is more for lone pair of electron. The lone pair of electrons wants to be more stable than even bond pair, because bond pair is being shared between two nuclei. So here what happens is, here you are having a bond pair of electron in sp3 hybridized orbital, and the other the lone pair of electron is in sp3 hybridized orbitals, and the other bond pair electrons are also in sp3 hybridized orbitals. Imagine if it was sp2 hybridized orbital. So sp2 you can see 1s and 2p. So that means 3 orbitals are involved. So it will give you 3 sp2 hybridized orbitals. So these are the 3 sp2 hybridized orbitals, 1, 2 and 3. So so imagine this is forming the bond. So these are the bond pair of electrons. So then sp2 hybridized orbitals. So you will say, yeah, electrons are more happy here, electrons should have been here, because sp3 electrons in sp3 is not as stable as electrons in sp2, because more as character, closer towards the nucleus, more stable. But what happens here? The lone pair of electrons which needs maximum stability is in the least stable orbital, it is in p orbital. You see here all this bond pair in sp2, but the lone pair is in a p orbital. We saw p orbital, electrons are least stable in p orbital. Let me show you once again. See, electrons are least stable in p orbital. So it says rather let the bond pair of electrons and lone pair of electrons be in sp3 orbital. So the bond pair rather be in sp3 orbital, which is less stable than being in sp2, but they cannot afford to have lone pair of electron in p orbital. So rather it stays in sp3 hybridized orbital, and therefore carbanions are trigonal, uh, are pyramidal, trigonal pyramidal in shape, and it is sp3 hybridized. For the same reason, because ammonia has lone pair of electron, water has two lone pair of electrons, they cannot be sp hybridized or sp2 hybridized, they are in sp3 hybridized, because the lone pair of electrons cannot afford to be in p orbital, where they are farthest from the nucleus and least stable. I hope you enjoyed the video. Thank you very much.